The first thing we're going to learn in Chapter 10 is about recursive formulas. We need to be able to go back and forth. So we'll have to be able to list a sequence from its recursive formula and then find a recursive formula from its sequence. So let's start where the idea of recursive formulas and sequences actually even come from. So let's say you have some data, and that data is in sequence. It's in very order. Like first day you have a number, the second day you have a number. So you have a first number, a second number, a third number, a fourth number, a fifth number. So if those numbers are specifically arranged, we can call they're arranged in a sequence. That means the first number corresponds with a certain number. The second number is a specific number. So the value of a term can be related with the number of the term. So for example, A of 1 is 78, or A sub 1 is 78. And both ways to write that, you're talking about position 1. And the first one, in the first example, position 1 is listed as the domain, where the x usually goes, right? And the second way we wrote it, the position 1 was a subscript, okay? And the actual term is the range element, the 78. So the term is 78. So the difference between a sequence and a set of numbers is that order is important in a sequence, but not in a set. So our definition of sequent is a function. So it's going to be a function. The domain is the natural numbers, okay? And so we have these function values, a sub 1, a sub 2, a sub n, are the terms of the sequent. So those tell us what we're looking at. A sub 1 is the first number. A sub 2 is the second number. A sub n is the nth number. Okay, so being the first, second, and nth terms. The nth term is what we call the general term, because we don't actually know what specific number we're looking at. Like, are we looking at the 20th number, the 100th number? We're just talking about a general term. So a listed sequence may not indicate the pattern for finding terms further down the list. A way that we do that is finding the recursive formula. Think of the recursive formula as how you get your answer, right? How you can get your answer. So the definition of a recursive formula is that it expresses the general term in terms of the previous term. So again, you're trying to find that nth term, and you're going to make a formula using previous terms. So for example, we have a sub n equals a sub n minus 1 plus 3. That right there is an example of a recursive formula. So a sub n is what we call the general term. So we need a formula on how to find the general term. And we have to use previous terms to define it. Well, we have equal a sub n minus 1. Since we're subtracting 1 from n, that is going to be a previous term. So this is an example of a previous term. All we had to do was subtract 1 from our general term that we're talking about. And then we add 3, so that makes it a formula. Okay? They tell us that a sub 1, our very first number, is the number 1. And we want to start finding the first terms of the sequence at n equals 2, because we want our n to be greater or equal than 2. So to do this, we're going to plug in 2 for n. So a sub 2, again, we plugged in 2 for n, is equal to 2 minus a sub 2 minus 1. 2 minus 1 is 1. So a sub 1 plus 3. Well, a sub 1 was 1. So we have 1 plus 3 equals 4. Now let's find a sub 3. So a sub 3 is equal to a sub 3 minus 1. Well, 3 minus 1 is 2, so we're going to plug in a sub 2 plus 3. Well, we know that a sub 2, we found out in the previous substitution that a sub 2 is 4. So I'm going to substitute 4 for a sub 2. So I have 4 plus 3, which is equal to 7. Now I know that a sub 3 is 7. Now let's find a sub 4. Well, a sub 4 is equal to a sub 4 minus 1. 4 minus 1 is 3. So a sub 4 is a sub 3 plus 3. I know that a sub 3 is 7, so we have 7 plus 3, which is equal to 10. Last one, we have a sub 5. So remember, our formula, our recursive formula, is just n minus 1. So if we're letting n be 5, that means our formula is a sub 4 plus 3. And we know that a sub 4 is 10, so 10 plus 3, which is 13. So the sequence listing, how we'd actually list the sequence, we would just list not the actual terms, not the a sub 1, a sub 2, a sub 3, just the actual numbers. So 1 was a sub 1, so we have 1, a sub 2 is 4, so we have 4. So we have the sequence listing as 1, 4, 7, 10, 13, and then we'll put a dot, dot, dot to indicate that you could keep going. Example 2, let a sub 1 equal 1 and a sub 2 equal 2. Our general term, a sub n, our recursive formula, is a sub n minus 1 times a sub n minus 2. And we want to find n equals 3, 4, 5, dot, 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 and keep going, right? So we want to find a sub 3, a sub 4, a sub 5. So we'll plug them into our recursive formula, right? So here's our recursive formula. So first we're going to find a sub 3. So when we are finding a sub 3, that means n is equal to 3, right? So 3 minus 1 is 2, which is how we got a sub 2, times 3 minus 2 is 1 is how we got a sub 1. But a sub 2, they told us, was 2. So we're going to substitute 2 for a sub 2. And then a sub 1 was 1, so we're going to substitute 1 for a sub 1. So now we have the answer 2 times 1 is 2. So now we know that a sub 3 is 2, and we can use that in future recursive formulas. For example, we're going to use it in when we're trying to find a sub 4, the fourth term, right? So 4 minus 1 is 3, so we need a sub 3 times 4 minus 2 is 2, a sub 2. We need a sub 3 times a sub 2 to find a sub 4. So we need the third term and the second term to find the fourth term. Well, our third term, our a sub 3, was 2. And our second term, our a sub 2, was also 2. So 2 times 2 is 4. So our fourth term, a sub 4, is 4. Now let's find our fifth term, a sub 5. So 5 minus 1 is 4, and 5 minus 2 is 3. So we're looking for a sub 4 times a sub 3. A sub 4 was 4, and a sub 3 is 2. And 4 times 2 is 8, which means our a sub 5, or our fifth term, is 8. Now let's go backwards. This time we're actually given the sequence 2, 4, 16, 256, and we want to find the recursive formula. So remember, if they gave us the sequence, that means this 2 is a sub 1, this 4 is a sub 2, this 16 is a sub 3, and the 256 is a sub 4. And we're trying to find a sub n, right? The recursive formula is in the general term. So let's look at this pattern. We have 2, 4, 16, and 256. Notice that 4 came from 2 squared, and that 16 came from 4 squared, and that 256 came from 16 squared. So you're getting each number in the sequence by squaring the previous number. So to get a general term, you have to square the term right before the general term, which is what we call a sub n minus 1, right? the previous term to a sub n is a sub n minus 1, and then we square it, right? However, we have to indicate what our first term is, and our a sub 1 is 2. All right, there are different types of sequences that we want to learn. The first one is an arithmetic sequence, okay? And that is where you get your consecutive terms by adding a constant, right? That constant is actually what we call d. So the general equation for an arithmetic sequence is a sub n equals a sub n minus 1 plus d, where d is that common difference, right? Common difference. So an example of an arithmetic sequence is 1, 3, 5, 7, 9, because the common difference is 2. So our recursive formula would be a sub n equals a sub n minus 1 plus 2. This next example, we have 3, 2, 1, 0, negative 1, negative 2, negative 3, dot, dot, dot. This is our sequence, right? And they have a common difference of minus 1, right? Our common difference is minus 1. So our recursive formula would be a geometric sequence is where you have the consecutive terms are found by multiplying by a constant, and that constant is called a common ratio. So the general formula for a geometric sequence is a sub n equals r, that common ratio, times a sub n minus 1. So for example, if we have a sequence 2, 4, 8, 16, 32, to get from 2 to 4, we multiply by 2. To get from 4 to 8, we multiply by 2. To get from 8 times 16, we multiply by 2. Each time we multiply by 2, so that is our common ratio. That is our r. So our recursive formula would be a sub n is equal to r or 2 times a sub n. Let's look at this sequence, 27, 9, 3, and 1. Each time we're dividing by 3, which is the same as saying multiplying by 1/3. So our r is 1/3, that's our common ratio. So our recursive formula would be a sub n equals 1/3 a sub n, or 1/3 a sub n minus 1, right? 1/3 of the previous number. The next sequence we're going to learn is the Fibonacci sequence. So each term is obtained by adding the previous two terms. So a sub n is equal to a sub n minus 1 plus a sub n minus 2. So the previous two terms. Just so you know, the Fibonacci sequence will always start with f of 1 equals 1 and f of 0 equals 0, right? So 0 plus 1 is 1, so f sub 2 would be 2. So our Fibonacci sequence looks like 0, 1, 1, 2, 3, 5, 8, 13. So notice we got 8 by doing 3 plus 5. We got 3 by adding 2 plus 1. 5 we got from 2 plus 3. 13 was 5 plus 8. So you keep adding. The next sequence we want is a factorial sequence. Okay, so this one is a little different than a geometric sequence, because the geometric sequence you just added by a common ratio. And this sequence, we're actually going to multiply by the position. We're going to multiply our n, right? We're going to multiply our term by the previous term. Okay, so we multiply our position, which is our n, by the previous term, a sub n minus 1. So for example, this is 1, 2, 6, 24, 120. So notice that 6 is the same as multiplying 2 times 3. So our previous term was 2, and we multiplied it by 3, which is the position of the 6, right? And so when we got 24, we multiplied by 4, which is the position of 24, times the previous term, which is 6. So 6 times 4 is 24. The next type of sequence is a harmonic sequence. A harmonic sequence is the reciprocal of an arithmetic sequence. Remember, arithmetic is when you are adding the same number over and over and over, what we call the common difference. So let's give the first 5 terms of a sub n equals 1 over 1 over a sub n minus 1 plus 5. And then we need to tell us what kind of sequence is it. So a sub 2 is 1 over 1 over 1 over 3 plus 5, which is equal to 1/8. A sub 3 equals 1 over 1 over 1/8 plus 5, which is equal to 1/13. Here's a sub 4 and a sub 5. So if we list the terms of those sequence, we get 1/3, 1/8, 1/13, 1/18, 1/23. And if we were to flip those back up, take the reciprocals, it would be 3, 8, 13, and 18. So that means that a sub n is equal to 1 over b sub n, or when we took the reciprocals. That means that a sub n is a harmonic sequence. Go ahead and try 10.1, 2 through 6 evens.